Okay, guys, so for section 3 of unit 15, we're looking at systems of two variable inequalities, okay? So the first thing you want to do here, you want to graph both boundary lines, okay? Now, if it's a system of whether it be equations, inequalities, there's usually going to be more than one, okay? So you're going to graph both boundary lines. The next thing you're going to do is you're going to shade the half planes that make each inequality true, okay? So we're used to already shading the half plane that makes one inequality true, so this is really no different. We're just going to shade each half plane that makes each inequality true. Okay, so we're going to have two different areas that are shaded. Okay, and the third part is we're going to erase the shadings that do not overlap. So what that's saying is the shading that is the overlap of the separate inequalities, okay, the overlap shaded area is actually our solution to that system of two variable inequalities. So there's bound to be some overlap somewhere, okay? That overlap is actually our answer to our system of inequalities. Other than that, the process of graphing these and shading them is going to be the exact same as what we're used to. So if we're looking at number 1, we have y is less than negative 2x plus 6, and y is greater than or equal to x minus 5. So when we look at the first one, right, our y-intercept is 0, 6, and our slope is negative 2 over 1. Okay, so we're going to put a point at 0, 6, and then we're just going to use our slope, negative 2 over 1, to go down 2, right 1, down 2, right 1, and plot a bunch more points. Okay, now when we look at this, we can notice that it is strictly less than. Okay, this graph is strict, or this inequality is strictly less than, so we're going to have a dashed line connecting all those dots. Okay, so there's our first boundary line. Now what we can do with this is what we're used to doing, right? We're used to picking a point and finding out if it makes the inequality true or not. So we're going to test the point 0, 0, which of course is the easiest point that we can test, right? It's not on the line. We can pick any point that's not on this line. Okay, so we pick the point 0, 0. Once we plug 0 in for y and 0 in for x, we end up with the inequality 0 is less than 6, which is true. Now, since this is a true inequality, we would shade the half plane that contains our test point. Well, this left half is the half that contains our test point. Okay, so we'll shade that part. So that's the first half of what we're trying to do here, okay? Now, the second part, we have y is greater than or equal to x minus 5. Now, we have a y-intercept at 0, negative 5, which is going to be down here, and our slope is just 1. So we're just going to keep going up 1, over 1, up 1, right 1, up 1, right 1, right? And of course, this point way out here, we skipped some in the middle, but as you can see, if we keep going up 1, right 1, that's where the point's going to end up being. Our slope is just 1 over 1, okay? Now, this line is going to be a solid line because it's greater than or equal to, okay? So there's our greater than or equal to line right there. It's a solid line because it's greater than or equal to. Remember, that line under the inequality sign is a dead giveaway of what kind of line it's going to be. It's a solid line underneath. It's going to be a solid boundary line. Okay, now we're going to test another point. Well, guess what? 0, 0 is also not on this line, so let's use it again. So when we use 0, 0 and we substitute in, we're going to get 0 is greater than or equal to negative 5 as our final simplified inequality. Now, 0 is greater than or equal to negative 5, so this is also true. So now we'll shade the half that contains 0, 0 again. Here we are shading that whole half. Now notice there is an overlapped area here. This whole section right here is the overlapped area. There's both that kind of salmon colored shade and the blue color. Okay, that's the overlap. It's kind of making a purple there. But there's also this blue area and the salmon area. Well, the next part, number 3 of what our initial 3 main points said today, were to erase the shadings that don't overlap. Okay, so that's what this step is showing right there. These are our steps that don't overlap right here. Right, these parts right here, there's no overlap. It's just blue or it's just salmon. So we erase those shadings to show our true final solution right there, that purple area. Okay, so that would be graphing this system of inequalities right here. That would be the solution to it. Okay, so let's look at the next one. So the next one, we have y is less than or equal to negative x plus 11 and 2x plus 3y is greater than or equal to 12. Let's deal with the first one up here. We have y is less than or equal to negative x plus 11. Our y-intercept is all the way up at 0, 11. Okay. We're just going to do the bottom one first. Sorry about that. Okay, so if we're looking at the bottom one, what we can do first is, of course, we want to put it in slope-intercept form. We do that by subtracting 2x from both sides. And when we subtract 2x, we know 2x minus 2x is 0, and 12 minus 2x, those are not like terms, so we just write them next to each other. So we get 3y is greater than or equal to negative 2x plus 12. Now to solve for y, we divide everything by 3. I notice a lot of us are only dividing one term on this right side of the inequality by the number in front of y. You have to divide everything both sides completely by the number in front of y. Okay, so once we simplify this, we're going to get y is greater than or equal to negative 2/3 x plus 4. Now for this one, we know our y-intercept is 0, 4, okay, and our slope is negative 2/3. 0, 4 is right there on our y-axis here, 0, 4, and our slope is negative 2/3. We're going to go down 2, right 3, down 2, right 3, down 2, right 3, okay? So there's our dots right there, okay? Now, we know this is going to be a solid boundary line because it's less than or equal to. It's got that line underneath it, so it's going to be a solid boundary line. Okay, now looking at the next one, we have y is less than or equal to negative x plus 11. So 11, forgot we have to test a point first. Okay, hopefully you guys would have been stopping me in lecture there saying we have to test a point first. Okay, so we have to test 0, 0. 0, 0, again, is the easiest point you can test. It's not on a line, so let's test it. Okay, 0, 0, we plug it in. We end up getting 0 is greater than or equal to 12. We plug 0 in for x and 0 in for y. We get 0 is greater than or equal to 12. Now this one's false, okay? Since this is false, we shade the half plane that does not contain our test point. This is the half plane that contains our test point. This is the half plane that does not. So we would shade the half that does not contain our test point. Okay? Now we can move on to the top one. So this one's a little easier. It's already in slope-intercept form. We already have our y-intercept of 11, right? And our slope is negative 1 over 1. So let's plot our point 0, 11 all the way up here. Our slope is negative 1 over 1. We're going to go down 1, right 1, down 1, right 1, down 1, right 1, until obviously you get all the way as many dots as you can. Okay, now this line's also going to be solid because it's less than or equal to. Okay, so we have two solid boundary lines here because they have that equal to part under it, less than or equal to and greater than or equal to. Okay, so they're both going to be solid boundary lines. Now we need to test a point, so we can test 0, 0. Again, it's not on this line. It's an easy point to test. So we're going to pick 0, 0. We're going to see if it's true. Now we plug 0 in, we get 0 is less than or equal to 11. Is this true? Yep. So we shade the half that does contain our half, that point, our test point 0, 0, which for our blue line would be this whole section here. It'd be this whole half plane. Okay, so we shade that whole thing. Again, hopefully we can see that there are areas that are not overlapped, and then there's a whole area that is overlapped, this purplish area here. Okay, so our job is to erase the areas that are not overlapped to show our final solution of this overlapped area. Okay, and there it is right there. Okay, that would be our solution to this system of inequalities right there, that purple area. Okay, now moving on to number 3. We have 2x plus 6y is less than or equal to 24, and x minus 2y is less than 12. Now for this one, there's a couple different ways we can do this. Now notice the step that we showed right here. We have 0, 4, and 12, 0. Okay, some of us might be wondering, well, how did we even get that, Mr. McLaughlin? Why are we not just putting it in slope-intercept form like we always do? And I can tell you right now, you can do that. You can absolutely move this into slope-intercept form. But hopefully some of us remember what we can do with inequalities or equations when we are in standard form. This is in standard form. When you're in standard form, the easiest thing you can find when you're in standard form are the x and y intercepts. Now, right here, our y-intercept is found by dividing 24 by 6. Because if we notice, our x value for our y-intercept is 0. So if we plug 0 into our inequality, 2 times 0 is just 0, so this almost is just gone, and we're left with 6y is less than or equal to 24. Well, to solve for y, we just divide 24 by 6. So hopefully you remembered to find our intercepts. When we are in standard form, we can divide our solo number by our number in front of our variables. Okay, to find our y-intercept, we divide our solo number by the number in front of y. 24 divided by 6 is 4. And to find our x-intercept, 12, 0, we take 24, our solo number, divided by the number in front of x. Okay, so there's our two intercepts. Now the nice thing is we know these are linear, which means they're straight lines. Okay, these linear functions, okay, we can graph. We can just plot our two intercepts and connect them. Okay, now we know, hopefully, that this is going to be a solid boundary line. This is a solid boundary line because it's less than or equal to. Okay, so we can do the same thing for number 3. 4, of course. Hopefully you guys would have stopped me again. For some reason, I keep forgetting that we need to test these points. Okay, let's pick the point 0, 0 and test it. It's not on the line, right? Okay, so we end up with 0 is less than or equal to 24, which is true, so we shade that half. Okay. Now for the second part, we have x minus 2y is less than 12. Again, we can do the same thing here. We can divide our solo number by the number in front of y to get our y-intercept. 12 divided by negative 2 is negative 6, so 0 comma negative 6 is our y-intercept. And we can take 12 divided by the number in front of x, which is just 1. Remember, if there's no number written, it's implied that it's a 1, which is 12. Okay, so there's my y-intercept, there's my x-intercept. And again, this one is actually going to be a dashed boundary line because it's strictly less than. And now we need to test the point. Guess what point is not on this line? 0, 0. Let's test it. Okay, is 0 less than 12? We substitute our 0 for x, substitute our 0 for y. Is 0 less than 12? Yep. So we shade the half plane that contains that point. So we go ahead and do that. Okay, now our last step, hopefully we know and are familiar with it at this point, is to erase the parts that aren't overlapped. So we do that to get our final answer of shaded region here. That's in the purple for the system of inequalities. Okay, so that is it for today, guys. Let me know if you have any questions, and good job today.